Hi, and welcome to another episode of Casper on BI. Today we're going to do another deep dive. We're going to talk about composite models, aggregations, and some of the upcoming features that are coming. But we're not going to focus too much on the new upcoming features because when you understand the way that composite models work, when you want to combine data from multiple different data sources into a single report, and if you understand how your aggregations work, then you will also understand how composite models against analysis services models will work too. All right, so let's get going. So today we're going to talk about composite models and aggregations. We're going to talk about connecting to data. We're going to talk about composite models themselves. We're going to talk about aggregations, and we're going to talk about composite models vnext. So let's talk about connecting to data in Power BI. How does that work? In general, there are two ways of connecting to data. One is importing, and the other one is DirectQuery. When you do import, you'll get the best query performance possible because you're loading all that data into our in-memory engine. If you are in DirectQuery mode, then you get data freshness because there's no data being loaded into the model. When data refreshes on the back end, you just refresh the page in Power BI and you get new data showing up. Or when you have very big models and you don't want to load everything into Power BI. And really, I'm talking here about terabytes of data because the compression algorithms in Power BI are really good, the column store database. So sometimes you get to 10 to 20 times compression. So you can load a lot of data. I've heard customers recently talk about more than a billion rows of data in under a gig model. So if you do some tuning and you do some things like this, you can get a lot of data imported in Power BI too. There's few more things that differentiate the two. But today, before we had composite models, the situation was the following. You either were able to import all the data into Power BI, or you had to have the whole model in DirectQuery mode. So there was no mixing and matching. With composite models, this changed. But before we go into composite models, let's talk a little bit about the characteristics of each storage mode. First, it's importing data. So when you import data, you load data into our VertiPack engine, the engine that the Power BI team built from scratch themselves. And to date, it's still the fastest engine for analytical query patterns. It is built for analytical query patterns. It's built for showing facts and dimensions. It's built to support functions that you need a lot inside of analytical queries, like time intelligence functions. This thing counts. And many other functions are natively available and they're fast. Concurrency. It is built for concurrency. You can have hundreds or thousands of users hitting that database and it won't get resource constraints. You can create row-level security, RLS, in the model. So you can create security for people that are connecting to the model. There's one downside, obviously, data has to be loaded. It takes time to update, and obviously it also costs memory to load the data into. Now, there are many constructs that allow you to improve the time to load. For example, we have incremental refresh, which allows you to just load in parts of the data. Or you can create partitions where you load in pieces of data at a time, not everything at once. So these are some things that allow you to make it better. But still, if you have lots of changes, if you have a lot of data, then it will be hard to keep it up to date without a lot of additional work. DirectQuery, on the other hand, there's no data stored. So updates show immediately. Any query sent to Power BI will be translated to SQL. So you do something in Power BI, you create a visual, and that gets translated to a SQL query that gets sent to the data source. But some things are really hard to translate, like time intelligence. Can you imagine about the query that needs to be sent when you start doing previous year to date? Row-level security gets pushed too. So let's say you say, I want only people to see the data from region East through row-level security, then East gets injected on the query and being sent to the underlying data source. Now, all of this works, but there's a big dependency on the data source for performance and concurrency. If you just have an OLTP database that is optimized for your OLTP system and immediately you start adding a DirectQuery model to it that sends and sends and sends queries to the data source, you could be in trouble. And what that means is that the database won't be able to handle the analytical query patterns that Power BI sends. Now, on the other hand, also concurrency could be a problem. With SQL Server, probably not that much, but if you start talking about big data systems, then concurrency often is an issue. If you start hitting it with hundreds of people to your Spark node, then potentially you can get into trouble. The one big benefit of DirectQuery, and this is what a lot of customers want, is you can use single sign-on from the data source. So you use the row-level security as is defined in the data source. The people who are connecting to Power BI send a SQL query to the data source, and the data source now retrieves only the data that they have access to. Of course, you need to have single sign-on enabled. It works for a lot of different data sources, so that's good. So that's a benefit. Now, as we talked, let's look a little bit at what's happening under the covers. So SQL is being generated on the fly. So here we have a model, geography, customer, with sales that they do on a particular date, and we sell different products, and we have the reseller sales too, that is done by employees on a particular date too. Now I drag in year and sum of sales amount from my sales and date tables. What happens is a SQL query is getting generated and sent to the underlying data source. So to send a SQL query like this, select year, sum amount from sales, inner join date, group by year. Now, it's important to notice two different things here. One, it is doing an inner join automatically. So even though we are visualizing and looking at data from two different dimensions or two different tables, one dimension, one fact, it still sends an inner join. And the reason for that is we don't have to join it ourselves. The join has to happen somewhere, okay? Preferably in the data source. So now the data source joins the data already, and we only get the data that we need. The second most important thing to notice here is we're doing a group by, and we're doing a sum directly. So we're not getting the limit or the data itself, we're getting the already aggregated work done by the SQL Server database. Okay, that's important because we don't have to import all the data and we don't have to do a lot of work ourselves. We let SQL Server do the work. Okay, so we try to optimize as much as possible. Now, again, when joining data, we try to push the joins down. So again, here, I'm looking at sales by date and customer. We do an inner join on both. So one query is getting sent and the result set that's getting returned gives us exactly only the data that we need to visualize the data. So again, we try to limit the throughput on the wire. So not much data is actually getting returned to Power BI. So we don't have to do a lot of work in Power BI because if you have to join it yourself, it's going to be expensive. Okay. So here we did an inner join on date and customer, and we're grouping it again by year and name. Now, let's take a quick look here. Let's do a demo. So what I have here is a Power BI desktop file. It's connecting to my Synapse database. It has 8 billion rows of data. I already connected to it. You can see the field list here. So you see date, device, geography, events, operating systems, and users. So it's a events-driven table, and actually we can take a look at the model too. So we see here, we see the model. It has dates, it has devices, operating systems, users, events, and geography, and I've created relationships. Now, one important thing to recognize here is I've created my relationships, and I've done one particular important thing that's very important for DirectQuery data sources. I have turned on assume referential integrity. And what assume referential integrity means is it will, instead of doing an outer join that it's doing by default, it will go to an inner join. Inner joins are way, way, way faster in most data sources. So this will give you a significant performance boost. The reason why we're not having this set to default is that the Vertipack engine, the Power BI engine, by default does an auto join. So imagine you have sales that don't have any products, then you'll have a problem because you will, with an inner join, you will never see those missing cells. You will see them in VertiPack Engine. So that's the default behavior. So you'll never miss any data. We'll never have grand totals that are wrong without you even knowing. By this, we assume that you say, okay, I'm aware of this behavior and I'm okay with this. I'm going to assume it, that we have referential integrity, that I have my data quality in order, that I have the right products for the right set of facts. But it's important to turn it on, because if you don't turn it on, it's going to send outer joins, which are relatively slower. Okay? Okay, so now let's go. Let me go here. I'm going to my events table, and I'm going to drag in my count rows. And now it's going to send a query to the data source, and it's giving me count rows of 8 billion rows of data. And I want to look at this by geography. So I'm going to drag in geography name. This shows me a lot of data, but there's a lot of none too. Actually, so you can see the referential integrity here is okay. They just mapped everything to none, but I'm going to exclude it. And then I'm going to make it into a tree map so I can see the distribution better. So we see here US, China, Germany, England, UK, and we see the events by country. Okay. Now, let's actually see what happens under the covers. So again, before you can whip open DAX Studio, you can actually look at the gory details. But in this case, we don't need that. So what I'm going to do is I'm going to go to View, and we're going to click on Performance Analyzer. Okay, that's going to open a Performance Analyzer pane where I can do Start Recording. So I'm going to click on Start Recording, and now I'm going to click on Refresh Visuals. That will refresh all the visuals in the page, but also clear the cache, which is important. So we're going to click Refresh. Now it's going to start loading. So it says, okay, we're looking at the count rows by geography name visual, and it's done. So now it's important to recognize and see what's happening here. This is the total time it took. This is not the sum, as you can see, right? Because what happens here, the DAX query that we sent actually sends a direct query underneath it. Then it shows visual display to actually render the visual, and some other items that needs to happen. So what happens? We can click on copy query, and we can go to Notepad, for example, paste it in, make it a bit bigger. All right. So this is this DAX query that's getting sent, and it's sending, let's make it a bit bigger. We look at the geography name, and we exclude the none. You saw us do it, right? It generated this DAX to do it. And then I want to see by geography name the count rows. Okay? And that's it. And we auto do order by too in the DAX query. That generates a SQL query as following. Select top 1 million, geography name, and count big. The reason why we do the top 1 million is because we never want to return more than 1 million rows to Power BI itself. The top only talks about result sets. It doesn't talk about we can only look at 1 million rows, as some people think while seeing this. It says, oh, you only look at 1 million rows. No, it only means we don't want more than 1 million rows data returned to Power BI. And honestly, if you're returning more than 1 million rows to Power BI, you're in trouble anyway. That's not what it's built for. That's not what it's designed for. You should go to paginated reports and look at some report pages and things like this. Power BI is not the place to do it. Okay. So what it does, it's creating two queries, an inner join, one on the events table and the other one on the geography table. It creates that inner join, and then it joins them on geography IDs. Okay, so that's the join it does. And then again, it excludes the geography in name none, and also it excludes null values. So that's the query that's getting sent. The optimizer optimizes these queries as much as it can. So that's it. That's the query that's getting sent. All right. So now that we've seen kind of how it works, so you create a model that just generates the schema the way we've seen it here, and you can change the schema too, right? So you can go ahead and change the names and the columns and all of these things. You can create measures. So the count rows here is just a simple DAX measure. That DAX measure gets translated into a SQL query that is getting sent to the data source. All right, let's go back and take a look at the next level. So now we're going to talk about actually joining data across domains, also known as composite models. So here you see a schema. And from the schema, we want to see the sales amount from sales table and the reseller sales amount from the reseller sales table by year. But I just drag this into a visual. I just drag in year, I drag the sales amount column and the amount column from the reseller sales, and I put them in one visual, and it sends one single DAX query. But under the covers, I've created this model where sales and reseller sales are actually in two separate SQL Server databases. So they're actually in two different databases. But the user doesn't know. Actually, DAX doesn't know anything about it either. It sends this query, but the model now starts to figure out, oh, these are in two different SQL Server databases. We need to do something to actually join them up together. So what it does, it sends two queries. First, it sends a query. Actually, it sends three queries, but I'll show you this in a second. It sends two main queries. It sends one query, and it detects that the tables are in the same table. So sales and date are in the same SQL Server database. And then, as you've seen before, it sends an inner join into groups by year. It gets the sum of amount. But when we get to the new SQL Server database, the other side, I'm going to inject it with a semi-join. So we're going to inject it with dates that we got from the date table. So we query the date table again, the dimension, and we inject that into the fact table. So again, so that we can do an inner join. And because we can do an inner join, that means again that we don't have to query the entire database, because in the end, we have to bring them all together, right? So we have to combine them both in memory to get the results. But we want it to be similar in shape and size so we can easily join them later. So we want the result set to be the same. So what we do is we act like that date dimension is also part of the other database. We create that table in the SQL query and we inject it and send it to get the results that we want. So we get it by year, by date, so we can actually go ahead and join them together. And again, we can let the SQL Server do the work and give us only, like in this case, we're only getting results set for by those reseller sales, and we join them together. So let's actually go ahead and look at this. So what I have here is the same DirectQuery model that we saw before, right? So we have this model here, but now I'm going to add data from the other database to it. So I'm going to go to my recent source I did before. I'm going to click on this guy, connect to this database. That's going to open it up. I'm going to click on Composite Sales. I'm going to look at my invoices. I'm going to click load. So I'm going to choose DirectQuery, press OK. And the thing that it's going to do is going to show me a warning. So what does this warning mean? You've probably seen it if you did the composite models. Well, the warning means that we're going to inject data from one side to the other. If you're doing injecting data from one side to the other, it could potentially mean that you're exposing data to the other side because you're injecting the data. If you have a profiler running or you're doing something like this, then potentially you might expose that data security-wise. So you have to make a conscious decision if you're okay with this or not. Press OK. I'm going to load that data. I mean, you cannot get it in any other way, honestly. All right. So I'm going to stop my performance analyzer for now. And I'm going to delete this. I'm going to create a little table here that does by year. And it's going to do my events, count rows. And I also want to see how many invoices we were sent. So what was the revenue in the same years? So I'm going to drag this in too. This is going to take a second because now we're consolidating again across those two domains. Sometimes we call it islands too. But it was relatively fast. So what you see here is we're getting the same results over and over again. So this means something was not right. And I did forget something because it became part of the model. Obviously, what we need to do is we need to make a connection. We need to create a relationship. So again, we're creating a relationship. We cannot do assume referential integrity here because it's automatically doing it because we're injecting that dimension into the other side anyway. And again, here we are. Now it's part of the model. You don't see any difference. We're going to press OK. Now it's going to send the query again. And let's see what's going to happen now. And now we see we're getting the revenue amount by year, and we see different numbers. The grand total is still the same as we saw before. So what does the SQL query looks like now? Because this might be very interesting. So click on Performance Analyzer, start recording, and we're going to do refresh visual again. All right. And here we are, it's done. It's created, again, same thing, but now I'm going to copy the query. We're going to paste it into my notepad again, and we're going to see what's going on here. Now we have a really big table, a lot of queries. So first, again, same thing, right? It's pretty simple. I want to see by year, count rows, and sum of revenue amount. But also added is grand total row because we have a grand total here. We'll show you that in a second, what that means. So again, this one we've seen before, right? This is the same inner join by date key and by the events table and the date table, and we inner join it. Okay, that's simple. The next one we did is we are sending a query to the dimension table. So we're getting all the rows from the dimension table. Okay, group by date key and year. So now we get all the dates by year. Now we're going to inject that into the other side. So first, we do a select on the invoice date table, and we're going to join it with a query that we create. So we see here, and you see instead of years, we have numbers, values that we replaced it with to reduce it. Maybe it's long or there's something around it, but we try to get the dimension values and replace it with smaller values, so the query might be smaller. But the keys we cannot do. So we inject the dates, the keys too, and you can see every day in all those years, so it's quite a lot. It's all getting injected and unioned into one single table, and then it's joining them, and joining the two. And finally, we do a sum to get the grand total too. Okay, so that is doing quite a lot. But what happens now if we do something, for example, like this? If we do it by year, we filter it, and now we see only 2018. Okay, so now data is going to send, it's retrieving that data. And here we are. So again, table, we copy the query, we go back, we press Ctrl V. Now, immediately the thing you'll see is we only have data from 2018. Because what we did is we injected the filter on the dimension, and now we only get data for 2018, so we have less data. So this is important to recognize, right? All the filters that you apply on the canvas also get applied into the injections and on all the queries that we send to. So that's very important to recognize. The more you filter, the lesser the queries get. The less data the queries get, and the less data gets transported over the wire. Now, obviously, I didn't do much optimizations here. Like, for example, you see the query times actually gone up instead of down because I actually started adding queries. But as soon as you start creating indexes and things like this to actually optimize the model for its performance, you can get great results. But you actually have to look at the queries that are being sent, the patterns that people use the reports with, and use that to optimize the SQL Server database to get the best performance. Okay, so this is important to recognize. So going back, when we are joining across domains, we have to make sure that we query both sides, and finally we inject them together in memory. Okay, so that's composite models. Now, what happens? So composite models is now we have only still DirectQuery, right? We haven't mixed storage modes. Now we're going to start mixing storage modes. So this was the situation we had before, but now with composite models, we also added one more thing, dual mode. So you can have DirectQuery and import together in a single model. So that's pretty amazing. So for example, again, let's look at a situation like this. The white ones are DirectQuery, the blue ones are import. And again, we do the same thing here. We look at year and customer name and sales amount. All of these are in DirectQuery mode, so we send a single DirectQuery query. Pretty straightforward. But now we look at reseller sales and employee. Well, both are blue, so nothing happens here. No queries are getting sent. It's just getting the data from VertiPack directly. But now I want to do something else. I want to join data across storage modes. So we do year, product key, and sum of amount. Now what's going to happen is it's going to get the data, the dimension table from VertiPack. It's going to get the keys again. It's going to inject that into that other site to get the actual product names, to get the actual sales by product. So we're injecting that data again. So again, we have to combine data in memory to get results. We cannot push down the join. So again, we have to inject here. So again, when you're combining data across storage modes, we have to inject. There's no other way to be able to do it. But with dual mode, we can actually make this possible. So in this case, I have reseller sales, I have products, and I have date. I have put the date table in dual mode. And in dual mode means that it is both DirectQuery and imported. And when that happens, the engine automatically decides where it can get data from. So in this case, the fact table is in memory. So it decides to join with the date table in VertiPack. So it doesn't have to send a SQL query. So, but if I would get something by sales and date, then it would actually use my DirectQuery model. Okay. Now, let's take a look at composite models again, because composite models have been around for a long time, but pretty soon when we start having analysis services also supported in composite models, the understanding of composite models will become very important. So a composite model is a model that composes across multiple domains or islands and could use different storage modes too. When connecting different islands, it gets complicated and data needs to be merged in the engine. The best performance you will get is to not merge data from islands. If you do it, as you've seen, try to only use it for small tables and use visuals that are filtered down so we don't have to inject that much information. RLS, just like the filters I applied earlier, also gets injected on the query. Obviously, single sign-on also works. So if you have single sign-on on the data source, then it automatically gets handled by that on the data source. So row level security also gets defined. Okay, so again, important to recognize. The most important thing about to know and to remember about composite models is that it needs to inject data from one side and in the other side. All right, now let's talk about something else, aggregations. So aggregations is a feature that's built on top of these things because it's using dual mode and it's using composite models. Aggregations are an in-memory table to reduce pressure on DirectQuery data source and inefficient joins. It can be used to catch the 98% of queries in VertiPack, but still allowing users to see all the details. So imagine the scenarios that I was showing you before, where we have sales and customer, but sales are billions of rows of data, the 8 billion rows I showed you before, but now I create an aggregations data table. And it's a very small table. It just contains 1 million rows of data, but it doesn't contain data on the customer level. We grouped it by geography and date. Customers not. So all the queries now that are getting sent, so again, we're doing the same thing. So let's look at the query that does something like this. So I want to see the year, I want to see the city, and I want to see the sales amount. But observe something interesting here, because what we're looking at is sum of sales amount, but we're actually not using the sum of sales amount. We're getting the data from the aggregations table. So what the engine now is able to do is when you create an aggregation, it says, well, instead of actually getting the data from DirectQuery, we'll get it from the aggregation table. So we don't have to go and send SQL queries and all these things. We use VertiPack to get that through that data. And I'll show you in a second how to set it up. But this allows you to hit like probably 98% of the users in my organization just want to see the sales by geography and dates. But sometimes they do actually want to go to the customer. It's still possible. The engine will take care of it. And let me show you what it looks like. Because if I now want to look at customer by year and sum of sales amount, well, the customer information and sales information is not available in memory. So what it will do is it will automatically switch the date, because you saw before, date was blue, now it's white. It's in dual mode. So now we get the data by sales and customer and date. We send an inner join to the SQL database and we get the results. The user didn't have to know anything, because again, the same thing what happened here is he dragged the amount column from the sales table, just like before, but now it did a direct query and before it did a VertiPack query. All right. So let's go ahead and take a look at what this looks like. So what I have here is a model. And again, let me quickly show you the diagram view. This is our new diagram view. And what we have here is the same table, dates, events, invoice dates, but now I have an aggregations table. And the aggregations table is actually pretty small. You remember it was 8 billion rows, right? But if we now go into my date view, and we click on the aggregations table, you will see it's only 2 million rows of data. So instead of 8 billion rows that we had before, we have 2 million rows of data. And what I did in this date table, which I created with data flows, is we have the date key, we have the device, we have the geography, we have the quantity, we have the count of rows. Okay? So this will allow us to get the same metrics that we had before, but only over 2 million rows that are imported in memory. Even more importantly, let's go and quickly go in here and show you it's only 8 megs in size. So 8 billion rows of data we're reporting over, now of course not the lowest grain of details, but only almost 9 megs of memory. So what does it look like? Right now it doesn't do anything yet, so we need to set up the aggregation. For us to set up the aggregation, we have to do the same things we always do. We go here, we drag in date key. Okay, so let's create the relationships. Okay, yeah, make it active. Let's create the relationships. And now we actually have to go, and we can also do it by device, obviously. Okay, and I want to do it by geography too. Here we go. Okay, so now we've connected the aggregations table. But now we actually have to go ahead and define the aggregations. So we go and right mouse click and we do manage aggregations. So my aggregations table is my aggregations. And what I want to be able to do is, okay, so the count rows in my aggregations table, it reflects the count table rows of the events table. Okay, my sum of quantity reflects the sum of from the events table to the quantity. And I press apply. Now these things get applied. My aggregations get created. It automatically hides the aggregations table. So the user actually doesn't even see it. Go back in here, it's gone. But if I do this, I drag my events by count rows, it actually gets it from VertiPack engine, the one that is loaded from the aggregations table. And here's my 8 billion rows of data again. But now it's coming from VertiPack. And I'm doing it by date. Again, let's look at by year. Let's make it into a line chart and also by month. And you can see it's pretty fast. And of course I need to order the right way. Sort by year, month year. And now we see it's all pretty interactive. It's working the way it should work. But now let's see what happens if I do this. I do count rows by geography. Again, the one we did before. Now it's taking a bit longer, but not that long. So what's the trick? What's happened here? So I made this aggregations table, right? But we had these tables, and you can actually see already in the new diagram view that's recently released that they look a little bit different. So the colors mean different domains. Aggregation, this means that it's in memory mode. You see these are different lines. Because what happens here, if I look at my advanced model, these are in dual mode. So this means they're both imported and in DirectQuery mode. This one too, but geography is not. So I can make it into dual mode. Dual mode. Yeah, it has implications, I know. So we're gonna load it. Now it's loading that data from in memory too. So now it's both in memory and in DirectQuery mode. Should take only a second. Yeah, it's only 250 rows. So now this is also in, if I now go back in here and I do my performance analyzer again, and I do start recording, we do refresh of the visuals, boom, they're both done. And on both cases, you only see DAX queries. We don't see anything else. So no SQL queries are being sent. So what I've done here is I've created a piece of in-memory information. It was pretty small, 9 megabytes. But now we're able to still talk and analyze the 8 billion rows of data. Not through all the details that we want, but in the 98% this is good enough. We don't need the biggest and the lowest granularity. And it's still possible to get that. So if you go back in here and see, if I want to see the events by operating system, I'm going to drag this in. Events by operating system. And we drag that in. Now, we didn't have this in memory. It doesn't hate the aggregations. Now it's getting that data from the SQL Server side of things. So it's still possible. We didn't have to do anything. It still works. So the users won't even know what they're getting at and what they're doing. And this is really powerful. Like, this is one of the biggest features that have been released for some time, especially want to connect to those larger data sources, because the aggregation now helps us in several ways. It helps us in being able to connect to data sources that might not be as fast. So in this case, the Synapse database is pretty fast. But imagine that you're connecting to a Spark cluster and you're hitting it with hundreds of users, my report. Do you want those hundreds of users to all connect to the Spark cluster and send queries and really hammer that cluster to the limit? Or do you want to say, okay, well, I want my 98% or my 90% of the queries to be hit my very small aggregation, and the dimensions, they're usually small anyway. I want to be able to do that in VertiPack mode, but when they go down to the lower level, then they go to Spark. One thing more with aggregations that's actually possible is you can layer it too. With aggregations and composite models, you can imagine the following. Like, imagine you have a aggregation sitting in VertiPack, and let's say it's sales by years. And you look at sales by years, that is an aggregation. But as soon as you look at it by products, it comes from a Synapse database. But as soon as you want to connect to it like sales by individual sales transactions in the store, I want to hit my Spark cluster. You can do it because you can have composite models that one table of data comes from Synapse, one fact table comes from my Spark cluster, and the aggregations are stored inside a VertiPack. So that's possible too. and it's really powerful. But again, imagine and think about the fact that the injections are still in place. The data is going to get, especially when you put them in dual mode, it's really good to mostly put your dimension dual mode so we don't have to send the additional query for the injections. But it's still important to remember we still always have to inject. We cannot join across domains. That is impossible. All right. So now let's talk about composite models vnext. In the next version of composite models, you're not able to just connect to SQL Server databases as a composite. You'll also be able to connect to enterprise semantic models. So you can have a local model, which is your model that you have in Power BI Desktop, and you can extend it with one enterprise local model, but you can also extend it with more local models. So you can create one semantic model that can be connected from local models and extended upon. Okay? So what does it mean? Most important thing is it works exactly the same as before. Like the same things need to happen. But it will also allow you to connect in DirectQuery mode to Azure Analysis Services and Power BI. It will not support SAP BW, HANA, or on-premise multidimensional. So you cannot connect to those. Again, this is the state that it is as it is in today. The feature has still not been in preview. It will be in preview relatively soon, so it might change. But the most important thing that you can do with this feature is you can personalize an enterprise semantic model using your Power BI Desktop. You can create new measures, you can create new calculated columns, you can create relationships, you can rename objects, you can change formatting. All of these things are possible locally. But again, remember, still the same thing applies as before. So you can extend the model, combine multiple enterprise models. That's even cooler. So you have your local Power BI Desktop, you have an enterprise semantic model, a data set in Power BI, or an Azure Analysis Service that has a sales, and you have an Azure Analysis Services that has reseller sales. You can combine them into a single model, or you can combine this enterprise semantic model with a local source, let's say an Excel file, too. So again, to remember, as I told you before, it works mostly the same way. So there are no joins to be pushed down. So be careful when joining large tables. Make sure that you have dimension tables that are relatively small, nicely denormalized out there, because otherwise you will start injecting large amounts of data and moving large amounts of data over the wire, which adds overhead. Important to also to recognize, it works for both Pro and Premium in Power BI. Okay? So without further ado, let's actually go ahead and take a look at it. So what I have here is a Power BI Desktop. It's still empty. So now what I'm going to do is I'm going to connect to a Power BI dataset. I'm going to click on it. Now it's going to connect to the Power BI service. And it's going to get a list of all the data sets available. So what I've actually done is I've uploaded my model that we created before in the Power BI service. So here it is. It's in the Power BI service. It's the same report and model that we created before in the demos. But now I'm connecting to it as a data set in Power BI. So I'm going to click Create. But now what it's going to do, it's going to create a model in my local Power BI Desktop file connected to that data set in Power BI. So it's creating a DirectQuery model against that data set in Power BI. So now what you can see here on the right is the same field list as we saw before. We see dates, device, geography, my events, operating systems, but I'm not actually connected to the SQL Server database, and actually it even brought in all the relationships from the schema too. See, all the relationships are here, but I can make changes to it. This is different than before. When you connected to a data set, it was in live connect mode, but now it's in DirectQuery mode. So I can make changes. I can go on here and say my events to events. And we'll do here is count of events. Okay. So we made changes to that model, and I can obviously look at it. So I want to see the count of events as a line chart by month on the axis. And I want to filter it by year. I want to filter it by basic filtering. I want to filter it by 2018. And 2019 for now. Because what I want to do is, again, because we're in DirectQuery mode, you see everything here still works. So I can import data from somewhere else. And I happen to have a projections Excel spreadsheet here that I want to compare. So the data, I've projected data from 2019. So I want to get that into my Power BI desktop file that is connected to that data set with my local Excel spreadsheet. So again, I need to close Excel before I can import. I actually going to filter this for 2019 only. And I'm going to click on Excel. I'm going to click on projection. And now we'll get the default Excel import showing up. I'm going to press load. And obviously there's no DirectQuery in this case, but I'm going to add it, import it. It's giving me the warning again because, and remember, nothing really has changed to composite models. It's still working the same way. It needs to inject the data into the DAX query that's getting sent. In this case, it's DAX queries. So we added DAX support for DirectQuery. That's really the work that's happening. But now the table is here and you see projection. And again, it has date and geography ID. So I'm going to do it by date. I'm going to join it. I'm going to leave geography ID for a second. I'm going to create the relationships. We're going to go back and we see the projection data here. And I can drag my projected amount on here. And boom, here we have the projected and the actual events from a data set in Power BI with my local Excel spreadsheet. That's pretty cool. But we can go even further because it's one model now. So we can actually go in and create new measures. So I'll create a new measure and I'm going to write count of events. And I'm going to do the projection minus the count of events. So we're going to do sum projected minus count of events. Press OK. I want to see the measure. I'm going to get rid of these two. And now we see the combined two. So we see actually we went under minus. Obviously, these numbers we have, we can change our DAX expression to make sure that we only get the values where we have the sum of projected, but you can get the drift. We can now start combining data from two different data sources. One is a data set in Power BI or Azure Analysis Services with local Excel spreadsheets, or even multiple data sets, a data set in Power BI with your Azure Analysis Services, and so forth. So this is a pretty powerful feature, but remember, the characteristics of composite models haven't changed. It's still needing to inject data. So make sure that you have a nice denormalized dimensions in your model. So and you're not going to join, like for example, two big fact tables in Azure Analysis Service with each other directly, because that's going to be pretty bad performance-wise, or really big dimension tables too. So that's important to recognize. Again, nothing really has changed. And with that, I hope I've given you a nice preview of composite models vnext, but also giving you much more understanding of how composite models work, what they do, and how you can use aggregations to speed things up significantly. And with that, I want to thank you for your time. I hope you've learned a lot. I will continue doing these on my channel, so make sure you subscribe below and hit the like button if you like it. If you have any questions, come to the comments and I'll answer them there. And with that, I hope to see you next time.